Alright, this is part 4 of our lesson on extending the number system. In this video, we will focus on performing operations with radicals. So we're going to add, subtract, and multiply them. Now, if I have 3 basketballs plus 5 basketballs, what do I have? Of course, I have 8 basketballs. Okay, that's why when we first learned about expressions with variables, if I have, for example, 3x plus 5x, what's that going to be? That's going to be 8x. Alright, for the same reason as the basketball. So 3x plus 5x means 3 of these things plus 5 of these things gives us 8 of these things. Alright, everything works just like basketballs. So if I have radicals involved, if I have 3 radical 7 plus 5 radical 7, guess what I'm going to get? That's right, I'm going to get 8 radical 7. Because again, this means 3 of these things plus 5 of these things gives me 8 of these things. Alright? Now, of course, you see that it has to be the same item. Alright, it has to be basketballs and basketballs, x's and x's, radical 7s and radical 7s. Alright, if I had a basketball and then a football, it wouldn't make any sense. So looking at number 29, we have radical 5 and radical 5. And of course, this is like, just having radical 5 means 1 radical 5. So if I have 1 radical 5 plus 3 radical 5, what do I have? That's 4 radical 5. Okay? Now, when you look at number 30, we have radical 17 and we have radical 34. Alright? That's 2 different things. You can't do it. There's nothing you can do with that. All right. If it was 5 radical 17 minus radical 17, all right, that would be like 1 radical 17. We would put 4 radical 17. But if the radicals are different, the radicand, then you can't do it. So in other words, technically the original problem is already in its most simplified form. So you could just recopy it and keep it the same. Alright, so watch out for that. So multiplication. When you multiply with radicals, just go ahead and, the number part, the non-radical part, you can just multiply. The rational part, you could say. 2 times 4 is 8. And then you can go ahead and multiply. As long as you have the same root, you can multiply. So this would be the square root of 30. So 8 radical 30. Boom. There you go. By the way, many of these problems your calculator will do for you. It's important that you know how to do them without a calculator, like I was just demonstrating. But it doesn't hurt to check your answer by trying to type it in your calculator. Now, do not give us a decimal. I don't want to see any decimals for this. So if we get a decimal, then you're stuck. You got to do it by hand. But let's check it out. If I did 2 radical 5, okay, times 4 radical 6. Okay, I'm seeing 8 radical 30, which is what we came up with. So in general, most of the time your calculator will do square root functions. So 5 plus square root of 5 plus 3 radical 5. Okay, 4 radical 5. Now, it took much longer to type that in the calculator than it would to just look at it and understand. So it's far better to know how to do it on your own. But I would be remiss if I didn't point out to you that your calculator can do that stuff. Now, the calculator will not handle cube root functions. It'll just give you a decimal. So you have to do these by hand. Now again, the index is the same. The root is the same. So whenever that happens, you can go ahead and multiply. So I've got the cube root. Now 25 times 5 is 125. Okay, so I've got the cube root of 125. Now, this one comes out evenly. Alright, I remember it from when we were doing this before. Alright, 5 to the third power is 125. So the cube root of 125 is 5. Okay, so as long as it comes out evenly, calculator could be helpful. So I could do, if I wanted to try it out, the cube root, I have to type in 3 and then do second caret, and that's the cube root of 125, and sure enough that is 5. So that is the answer to number 32. Alright, and because it came out evenly, I could have actually typed this whole thing in my calculator and it would have given me 5, but that only works some of the time. Okay, now look at this one. I have 11, but what do you notice that's different about these? Yeah, this has a cube root and this is a square root. Okay, that's like basketballs and footballs again. There's nothing we can do with this. Alright, you can't do anything. Just recopy it and leave it alone. Alright, you can't add a cube root and a square root together. You're stuck. Now, alright, number 34 is on another level because we have to simplify these things. So let's learn how to do that. Okay, so we're dealing with cube root. So let's get back to a place where we have the perfect cubes written on the side of the paper. Alright, so first we got the cube root of 48. Okay, so let's deal with that. The cube root of 48. Now, we need to simplify this down, is the thing, alright? Because, sure, you can see, we were just talking about the fact that, like number 30, this one we just stopped because the radicals are different. But obviously, this couldn't be simplified any further. Okay, the square root of 17, that's like a prime number. And 34 is 2 times 17, but there's no way, there's no perfect square in there that can be simplified. But these can be simplified, so we can't just stop and say, oh, nope, done, can't do it. We got to do it. And the way you simplify it is, first you have your chart. If it's a cube root, make a chart of perfect cubes. And then you ask yourself, which of these numbers will divide evenly into 48? And the first one you see, 8. 8 divides evenly into 48. How many times does it go? Well, you better know that it's 6, but if you didn't, 48 divided by 8. Okay, you know, 6 times 8 is 48. Okay, so the reason why that's important is because I need to rewrite this as the cube root of, and the first thing I write needs to be one of these. Okay, so I've got 8 right there. And we just saw there's 8 times 6. So I've rewritten 48 as 8 times 6. Alright, the first number had to be one of these perfect cubes. The reason why is because we know what the cube root of 8 is. Okay, what is the cube root of 8? Yeah, the cube root of 8 is 2. So that's why we put it first, so we can go ahead and do it. Alright, and do the cube root of 8. So that becomes 2. Now, what about the rest of it? Now, once you do the cube root of 8 and that becomes 2, what's left is the cube root of 6. Okay, and there's nothing you can do with that, so that's going to be the cube root of 6. I'll put that 8 back in there for now. Alright, so the cube root of 48 is the same thing as 2 cube root 6. Okay, so this is really 2 times the cube root of 6. Now, how about the cube root of 72? Let's do that as well. Okay, so the cube root of 72. Alright, so just like before, we need one of these numbers to divide evenly into 72. Okay, and 8, once again, 8 works. 8 goes into 72 evenly. Alright, how many times does 8 go into 72? You better know it. Right, it goes in 9 times. Alright, so this is 72 could be thought of as 8 times 9. Now again, the reason why we put this first is because we can go ahead and do the cube root of 8. And once again, the cube root of 8 is 2. But then we've also got the cube root of 9. Not the square root of 9. It's not going to be 3. Alright? 9 is not a perfect cube, so it's just going to stay the cube root of 9. Okay, so the cube root of 72 is the same thing as 2 cube root 9. Okay, unfortunately, there's nothing else that we can do. Alright, we have, again, two different numbers under the radical. So this is not basketballs and basketballs. It's 2 basketballs plus 2 footballs. Alright, you can't add them up and call it one thing. So we'll just have to stop there. That's as simplified as it can get. Okay. I think I'm going to stop the video right there. Alright, because it's going to take too long to do the other part. So this will be a short video, but we'll pick up the next video. We will add and subtract some polynomials. I'll see you on the next video.